Friends, good morning students. Today we are going to discuss some examples on triangles, and it is part 3. First theorem that we are going to come across is triple S congruence rule. In this congruence rule, it states that if three sides of one triangle are equal to the three sides of another triangle, then the two triangles are congruent. Here I have considered two triangle PQR and APC. In PQR, PQ is equals to PR AB and it is of 3 centimeter, and PR is equal to RAC and it is of 5 centimeters. So since it is hypotenuse, so it is of 5 centimeter. QR and BC are equal, so the base of the triangle is also equal and it is of 4 centimeter each. Here both the triangles are 90 degree at B and at Q. So you can see the three sides are equal and the angle is 90. Okay, then we go on to the next slide. In this triangle PQR and ABC, PQ equals to AB, QR equals to BC, RP is equals to CA. Therefore, triangle PQR is congruent to triangle ABC by congruence rule, SSS congruence rule. The next theorem that we will come across is theorem 7.5 of your NCERT book, and this theorem states the RHS congruence rule. RHS stands for right hypotenuse side. Here the statement of the theorem is, if two triangles, the hypotenuse and one side of the triangle are equal to the hypotenuse and one side of the other triangle, then the two triangles are congruent. It is also need to be 90. So here I have taken PQ and AB as equal as one side, RP and PR and AC is the hypotenuse that is equal, and these angles Q and B are equal and they are at 90. So we are going to write the statements like this. In triangle PQR and triangle ABC, angle Q is equals to angle B. So the first triangle whichever we consider, those triangle corresponding parts we need to write them first, and the second triangle that we have considered, those triangles congruent parts or equal parts that we will take it in the right hand side. So here first we are going to do the angle RHS. So R stands for 90 degree. So first we are going to write the number 1, that is angle Q is equals to angle B. Then we are going to do the hypotenuse according to the RHS. H stands for hypotenuse, so PR is equals to AC. And the third one is any side. Here I have taken the perpendicular, that is PQ and AB. So we can say the triangle PQR is congruent to triangle ABC by RHS congruence rule. Now we are going to discuss few examples. Today I am going to discuss 2 examples with you. The first one is example 7 of your NCERT book. Now here in question number example 7 we can see that it is said that AB is a line segment, PQ are the points opposite to the sides of A and B such that they are equidistant from A and B. That means the point P and the point Q are equidistant from the point A and B. Okay, now we have to show PQ is perpendicular bisector. Perpendicular bisector means bisector stands for half or making the side as half, and perpendicular means at 90 degree. So we need to show that at C the angle is 90 and AC should be equal to BC. AC should be equal to BC. Now let us move on to the solution part. Here solution, we are going to first write the given. So write, you are given that AP is equals to BP, AQ is equals to BQ. So these sides are equal and the bottom sides are also equal. We have to show PQ is perpendicular bisector of AB. That means we need to show AC is equals to BC and at angle PCA it is 90 degree. Okay, so here we are considering triangle APQ and BPQ. That means the first left hand side triangle and the right hand side triangle. The two differently shaded. One is longitudinally and one is laterally. Okay, in these triangles, when we are considering the triangle PAQ and PBQ, these are given. The first one is AP is equals to BP, AQ is equals to BQ, and PQ is a common side. So we have our triangle is like this. This is P, this is Q, this is A, and this is B. It is given AP is equals to AB, AQ is equals to BQ, and PQ is the common side. So this line PQ is the common side. So we can say that the triangles AQB and APQ and BPQ are congruent by SSS rule. So by CPCT we can say the angle APQ, so the top angle, and the angle BPQ, again the top angle, are equal by corresponding part of congruent triangle. Now let us consider another triangle. This is for this one. The top congruency is for this one. Now the bottom congruency. For that triangle we are going to consider triangle PAB. So we are going to consider the triangle APC and BPC. So for here we know that these sides are equal. AP is equals to PB, that is equal. The angle APC and BPC is equal. From above we can say that. Okay, and PC is the common side. So PC is the common side. Here we got two side and one angle. The angle is included angle, so the congruency will be SAS. So triangle PAC is congruent to triangle PBC by SAS rule. From CPCT we can say that AC is equals to BC. AC is equals to BC. So the first part, that PQ bisects AB, bisecting part is proved from the equation 1. This equation, that AC is equals to PC. So the bisecting part is done. Now we need to prove that the angle PCA is 90 degree. So from congruency also we can say these two angles are equal. By CPCT, see, so this line is also true. Angle ACP and angle BCP are also equal by CPCT. Now when we add these two, it is 180 by linear pair. Linear pair means the angle lie in a straight line. So angle APC plus angle BPC is equals to 180 degree by linear pair. Since the angle APC and BPC are equal, we can write as this one 2ACP. In place of BCP, we can also write ACP and write 2ACP is equals to 90 degrees. So angle ACP is equals to 180 by 2, that means 90. This is our second equation. So from equation 1 and equation 2, we can conclude that PQ is a perpendicular bisector of AB. So this was our second example, first example. Now let us move on to the second example. In second example, it is said that P is a point equidistant from the two line L and M. So L and M are the two line, and P is a point which is equidistant from the line intersecting at the point P. So through A we are going to draw a straight line, and on that straight line the point P lies. The point P is equidistant from L and M. Show that the line AP bisects the angle between them. So we need to show that AP bisects the angle between them. The angle PAC is equal to PAB. This is what we need to show. Now, our diagram was like this. This is L, this is M. Here was our A, this was our P, and we have B above and C below. So you are given a line L and M. First we need to write the given. Intersect each other at the point A. Let PB be the perpendicular on L and PC be the perpendicular on M. We need to show PB, it is given that it is equidistant, so PB and PC are equal. We need to show PAB is equals to PAC. So how we are going to prove? So here it is. Let us consider the two triangles PAB and PAC. So here if I enlarge the diagram, we have C over here, P as here, B and A. So we are going to consider the above triangle and the below dotted triangle. Okay, so here PB is equals to PC, already given. Angle B and angle C is 90, that is PBA and PCA is 90, and PA is the hypotenuse. PA is the common side to both the triangle. So by RHS means right hand side, hypotenuse and one side should be equal. So the triangle PBA and PCA are congruent by RHS rule. So by CPCT we can say angle PAB and angle PAC are congruent to each other by equal by corresponding part of congruent triangle, since the triangle PAB is congruent to triangle PAC. So this line is also proved. So we can say that PA bisects angle A. PA bisects angle A. So today till this much. Thank you very much, students. Hope this tutorial is helpful for you.